In this example, we will be looking at how you can apply Boyle's law to solve gas law problems. So this question, it tells us a gas occupies 1.56 liters at 1 atmosphere. What will be the volume of this gas if the pressure becomes 3 atmospheres? So here we know that we're given a volume and we're given 2 pressures. The atmosphere is a unit of pressure. So our first thing that we should do is we should start to define all our variables in a data list. So P1 is the initial pressure, V1 is initial volume, final pressure is P2, and then the final volume is V2. So then we can start to pick out the data from the question. So the initial volume, we know that that's 1.56 liters. We're asked for the final volume. It's also going to be in liters. The initial pressure is 1 atmosphere, and the final pressure is 3 atmospheres. So our next step will just be to write the relevant equation. So Boyle's law is given as P1 times V1 equals P2 times V2. And then we're asked for V2, so the final volume, so we will solve for that. The way we can do that is divide both sides of the equation by the final pressure. So then we'll be left with V2 on its own. So V2 equals P1 V1 over P2, the final pressure. Then we can sub in all of our variables. So 1 atmosphere times 1.56 liters divided by 3 atmospheres. And then we're going to get a value of roughly 0.52 liters. So therefore, the new volume will be 0.52 liters. So again, we defined all our variables, we used the relevant Boyle's law equation, isolated the variable we wanted to solve for, subbed in all of our information, and then we got a final answer. Keep in mind here that units of volume, it doesn't necessarily matter what units of volume we use in a Boyle's law problem, as long as they are the same in the end. So that's why we got a volume of liters at the end. We also know that conceptually this makes sense because due to the relationship between pressure and volume as given by Boyle's law, it would make sense that if the pressure increases, then the volume is going to decrease.